Welcome to the video lecture. This is Amarnath, Assistant Professor of Mathematics, Department of Humanities and Sciences. Under the course Matrices and Calculus, we are discussing about the system of linear equations and solving the homogeneous system and what is non-homogeneous system in this video lecture. Let us see the previous one. We have studied about inverse of a matrix. Then what is the way to find inverse of a matrix using Gauss-Jordan method. And we have discussed 3 by 3 and 4 by 4 matrix inverse using Gauss-Jordan method. In present lecture, we are going to concentrate on the application of the rank, that is solving the system of equations. That is linear system of equation, means first degree equations. So in that one we have two types of systems. We have homogeneous system and non-homogeneous system. Present video lecture we discuss homogeneous system solution and consistency and inconsistency of system of equations. Now, first of all, what do you mean by the system of linear equations? That is the first degree equations in n unknowns. Look at this here. I have given the some equations here, right? So a11 x1 plus a12 x2 plus and so on a1 and xn. So it is a first degree equation in n unknowns. Okay, a2 second row or second equation a21 x1 plus a22 x2 plus and so on a2n xn is equal to b2. Like that we have some number of equations in first degree. Why it is called linear means the degree of each variable x power 1, x1 power 1, x2 power 1, it is a first degree equation. So it is called linear. And a simultaneous equation, that more than one equation should be satisfied by the solution. So that is a simultaneous equation we are calling. And here mth equation am1 x1 plus am2 x2 plus and so on amn xn. Here the b1 b2 so on bm are constants. x1 x2 x3 so on xn are the variables where we need to calculate, satisfying all the equations at a time. That is called simultaneous solution. So at a time, simultaneously means at a time any set of solution will satisfy first equation, second equation, third equation. How many equations are there in the system? That all will be solved by these equations, system of solution, right? That type of solution we are going to solve. Again, this can be classified into two types of systems. One is homogeneous, another one is non-homogeneous system. So before going to that one, this system can be written as in the matrix form Ax is equal to B. This is called matrix form. This system we can write in the three matrices. One is called A and X, A and B. So A is equal to, which contains coefficients of the system of equations. What are that one? The first equation. So A11, A11. Second variable coefficient, X2 coefficient, A12, A13, so on, right? Next A1n. Second equation, X1 coefficient, A21, A22, A23, so on, xn coefficient A2n. Like that we have that equations. The last equation I am taking here, x1 coefficient is am1. Next x2 coefficient am2, am3, so on, that is amn. So we are writing the coefficients of the unknowns or x1, x2, x3 in a matrix form A. So here this is called coefficient matrix. Coefficient matrix. Right? Next, x is equal to unknowns in the system. What are unknowns we need? We are going to determine x1, x2, x3, so on. Here we have n number of unknowns, xn. These are called unknowns matrix. Next, B matrix. B matrix means RHS. So in the equations B1, B2, B3, so on, at the right hand side, whatever the constants we have, we are writing in a column matrix. B1, B2, so on, Bm. Okay. So this is X matrix is called unknown matrix. Unknown matrix or variable matrix also we can call. Unknown we can write, or we can call as a variable also. A variable matrix or unknown matrix. And this B matrix is called constant matrix we can call, or RHS matrix, or we can call as a constant matrix. Anything is okay. constant matrix. So any given system of linear system of equation can be written in the matrix form. Ax is equal to b, we call. That means if you multiply a and x, we get b matrix. Such a way we have written the system. So whenever we are going to solve the system of equations, we write in this form. Ax is equal to b. Now here Ax is equal to b, again we are classified into two ways. We said discuss, that is the homogeneous and non-homogeneous. Before that, here I am going to tell augmented matrix. Just I am going to write here augmented matrix. What do you mean by augmented matrix? Means it is nothing but A matrix and B matrix together we write. So further I am going to use, that's why I am defining the augmented matrix in advance. Means here the A matrix and this column matrix B will be attached as a last column. So here A matrix, complete matrix. So what we have taken A matrix here, that is A11, A12, so on A1n. Next A21, A22, so on A2n. Next so on AM1, AM2, so on AMN. And attach to the column B matrix. So B column, this matrix will attach B1, B2, so on BM. So A matrix, B matrix together we call augmented matrix. So further we use this matrix. So that's why here itself I am defining. Okay. So this is a representation of the given system of equation in matrix representation. Okay. Coefficient matrix, unknown matrix, and the constant matrix or RHS matrix. A and B together we call augmented matrix. Now, so here small two definitions, that is a consistency and inconsistency of the system of equations. When we can say one given system is said to be consistent, and when we can say inconsistent. If the given system has at least one solution, at least one, maybe one, maybe two, maybe three, maybe infinite, at least one solution is there, we call the given system is consistent. Suppose there is no solution at all for the given system, then we say the given system is inconsistent. No solution means that is inconsistent, at least one solution means consistent. Again here there is a possibility, whenever the system is consistent, it may have unique solution, it may have infinite number of solutions. In both the cases we say that is consistent. No solution means inconsistent. Generally, if the given system equation is given, Ax is equal to B, one system is given. So then what could be the possibilities in finding the solution? There are the three possibilities generally we discuss. The first one is unique solution. The system may have unique solution. Second option, it may have infinite number of solutions. Infinite number of solutions. My third one, we have no solution at all. Any one of the situation will arise for the given system. Depends on the system, depends on the system of equation. Maybe only one and only one solution we call unique solution. You can give n number of solutions, 10, 100, 1000, how many solutions, what that many we can give for some systems. We can call that is infinite number of solution. Sometimes solution never exists. No solution, inconsistent, that is the situation may arise. So out of these cases, now we have to find which case will arise for the given system. So let us find the next one. Here I said now the given system can be classified into two ways. Maybe the homogeneous system and maybe the non-homogeneous system. Non-homogeneous. So here Ax is equal to B is said to be homogeneous if B is equal to 0. Homogeneous system of equations, and Ax is equal to B, B not equal to 0, then it is said to be non-homogeneous. So the general student will understand very easily with the example. Look at this homogeneous system. Suppose we have the system of equations 3x plus 2y minus 4z is equal to 0. X plus y plus z is equal to 0. See, 2x minus y plus 3z is equal to 0. Look at this system. RHS part completely 0. And here B matrix is 0. If you write in the Ax is equal to B form, and here RHS part completely 0. Then we call the system is homogeneous system of equation. Suppose in that one at least one value, one B value is not equal to 0, then we call the system is non-homogeneous system. Look at the Example for non-homogeneous system. Suppose x1 plus x2 minus 2x3 is equal to 0. Here x1 minus x2 is equal to 0. 3x1 plus 4x2 minus 6x3 is equal to 0. Okay. So, and here at least suppose I am taking one value is not equal to, suppose here I am writing 4. Here I am writing some 6. Right. See, here two values are not 0. Maybe one value is not 0 also, okay. So, this is here completely RHS part B matrix we call completely not 0. Maybe one value is 0, maybe two values are 0, but all values should not be 0. Such a system we call non-homogeneous system of equations, right? So, homogeneous system, non-homogeneous system. In our syllabus, both systems we have. So, first the student must able to identify the given system is homogeneous system or non-homogeneous system. Very simple. B is equal to 0, RHS part completely 0, homogeneous. RHS part not equal to 0, that we call non-homogeneous system. First we study about the solution of non-homogeneous system of equation, then we go for the system of homogeneous. Okay, right. Now, so first we let us consider the non-homogeneous system. So, homogeneous system we have discussed here, but here we discuss here non-homogeneous. First we discuss the non-homogeneous, then we go for the homogeneous. Okay, non-homogeneous system of equation. Here Ax is equal to B. So far we have discussed the any given system of equations can be considered the matrix form or can be reduced to matrix form. Ax is equal to B. So in both cases will arise, m is equal to n case will arise, and m not equal to n case also we will see. Both the cases we will see. So this is a generally system of equations, that is a linear system of equation in n unknowns, right? And here any equations are there, and it can be m not equal to n also. Number of equations are not equal to number of unknowns also possible. So in both the cases we discuss, that is a solution of non-homogeneous system we are discussing here. Then how we decide the type of solution? So we have discussed any system of equations as given, there may be the three possibilities. One is three possibilities how we discussed, that is so unique solution, infinite number of solutions, and no solution. That how you can decide that one means based on the rank. Nothing but is a rank application here we are doing. In intermediate level, so we can do the solution of system of equations, that is the only unique solution case, that is using different method. Matrix inversion method we have done, matrix inversion. Cramer's rule we have done, Cramer's rule, and a matrix inversion method. These two methods we have done. But there are their maximum possibilities what we have discussed there, that is only unique system of equations. At a unique solution exists in that case. But every time unique solution may not possible for the given system. In that cases, here rank method is useful. Means for the given system Ax is equal to B, I want to decide which type of solution is existing. That is unique solution, infinite number of solution, and a no solution. That one we want to discuss. That depends on the, where it depends means this completely depends on the rank of A and rank of augmented matrix A by B, and number of unknowns. N is equal to number of unknowns. These three things we consider and we decide which type of solution. So here clearly I have explained, if rank of A is equal to rank of A by B, so here rank it has a solution. Definitely there will be one solution if and only if rank of A is equal to rank of A by B. Suppose both the ranks are equal. See, here rank of A is equal to rank of A by B. Definitely there will be a solution. But solution means two possibilities. Maybe the unique solution, maybe the infinite number of solutions. That depends on the number of unknowns. Suppose the first case, rank of A is equal to rank of A by B unknowns, and this is equal to number of unknowns. So briefly we call R is equal to N. So the rank of A and rank of A by B equal to number of unknowns, then the system will be having unique solution. Unique solution. Now case 2. Suppose rank of A is equal to, if rank of A is equal to rank of A by B, both are equal, no doubt solution exists means both must be equal, but R is less than N. Suppose here first case 3 is equal to 3, rank is equal to 3, unknowns are equal to 3. But suppose we got the rank of the A and rank of A by B, we got 2, but unknowns are 3. Suppose unknowns are 3, so rank we got 3, unknowns are 4. So this type of cases are less than n case we call generally. In this case, system will be having infinite number of solutions. Infinite number of solutions. Or we call many solutions. Infinite number of solutions. Okay. So this is the first two cases where the system is consistent, said to be consistent because solution is existing, consistent. And the third case where the solution does not exist, that is third case, rank of A is equal to rank of A by B. So we discuss rank of A is not equal to rank of A by B, then we say system has no solution and said to be inconsistent. Okay, these three cases basically student has to remember. So rank of A is equal to rank of A by B is equal to n, then system will have unique solution. Rank of A is equal to rank of A by B, but rank is less than number of unknowns. Solution, but how many solutions means infinite number of solutions we call. And rank of A not equal to rank of A by B, we call no solution, and system is said to be inconsistent. Okay, and any other cases here, especially the second case is important where the students are getting confusion. In this case here, n minus r number of variables, n minus r number of variables will be selected as arbitrary constants. So second case, remember one small formula, difference how much we are getting. Suppose rank 3, so rank 3, unknowns 4, difference 1. Suppose rank 2, unknowns 3, difference 1, n minus r, 3 minus 2, 1, 4 minus 3, 1. Suppose 4 minus 2, suppose we got the unknowns 4, rank 2, 4 minus 2, 2. 2 arbitrary constants. So what do you mean by the arbitrary constant? It can take any value. So only 1, suppose difference n minus r is equal to k, 1. Suppose you are getting difference 1. We got rank 3, unknowns are 4, 4 minus 3, 1. Means one arbitrary constant. And out of the given variables, maybe the z, maybe the x can be k, or z can be k. Any one of the variable will take it as an arbitrary constant. Suppose difference we got 2, n minus r is equal to 2. Then 2 arbitrary constants. So x is equal to k1, y is equal to some k2. 2 arbitrary constants. So depends on the difference, we have to select that many arbitrary constants. Suppose out of 3 unknowns, 1 is selected as arbitrary constant, remaining 2 we have to find. So k means it is arbitrary, it can take arbitrarily any value. Suppose you want to give k is equal to some 10, 1, 3, 4, any value you can give. So one variable is in terms of k, other 2 variables also must be in terms of k. X must be in terms of k, y must be in terms of k by solving the system of equations. So total final answer will be in terms of k. So 2k comma 3k plus 2, like that you may get a solution. So you give k is equal to 0, one solution will be obtained. K is equal to 1 solution, k is equal to 3, k is equal to minus 1, k is equal to minus 2. How many values you will give to k value? You get that many solutions. So clearly we will discuss that all the things in the problems. So remember, whenever the system has infinite number of solutions, then definitely the situation arises, we have to select arbitrary constant, any one of the variable or any 2 of the variable, depends on the difference of n minus r. Remember the formula n minus r in the case of infinite number of solutions, right? Now, so let us solve one problem here. Solution of here non-homogeneous we are considering here, not the homogeneous. Solution of non-homogeneous system, first we discuss, then we go for the homogeneous system. So here look at the system, how can we say it is a so that here equations x plus y plus z is equal to 4, 2x plus 5y minus 2z is equal to 5 are not consistent. Here means not consistent means system has no solution using matrix method. And here our application of rank we are doing in the intermediate level, you have done different methods, but here we are using the rank concept, right? So look, let's take the given system. Given, so is a homogeneous or non-homogeneous? Given non-homogeneous, y sir RHS part not completely 0. Given non-homogeneous system, what are the equations? X plus y plus z is equal to 4, 2x plus 5y minus 2z is equal to 3, x plus 7y minus 7z is equal to 5. In matrix form we write. So matrix form. What is the matrix form? Ax is equal to b. So what is a coefficient matrix? What is which coefficient? X coefficient, y coefficient, z coefficient is the first row. X coefficient 1, y coefficient 1, z coefficient 1. Second equation, 2x plus 5y minus 2z is equal to 3. So x coefficient 2, y coefficient 5, z coefficient minus 2. Third equation, x plus 7y. So x coefficient 1, y coefficient 7, z coefficient minus 7. This is a coefficient matrix. X means what are the unknowns involved in this equation? Three equations, x, y, z. These are the three unknowns involved in this equation. Here we can write n is equal to 3. That is important. Based on the n only we are telling the type of solution. Next, since it is a non-homogeneous, B matrix will be existing. B matrix means RHS part 4, 3, 5. Now, so already we discussed that is, now first of all, what type of solution exists we have to find. The no solution, unique solution, infinite number of solution. That is using the rank of A and rank of augmented matrix. In the previous videos, we have clearly discussed how to find a rank of a matrix. So here we take augmented matrix. Because the solution will be decided by the augmented matrix. Take augmented matrix. What is augmented matrix? A and B together we call augmented matrix. What is augmented matrix here? 1, 1, 1, 2, 5, minus 2, 1, 7, minus 7. Attach column B. What is the B matrix? 4, 3, 5. This is called augmented matrix. What to do? Reduce to echelon form to find the rank. We have both echelon form, normal form is there, but the correct one is echelon form, so that we can find at a time both rank of A and rank of A by B. Because since we are using only row operations, this A matrix and B matrix will not be mixed together. So if you close the last column automatically, so means if you close the last column, we get the rank of A, and completely considering we get the rank of A by B. So echelon form is a better one to find rank of A and rank of A by B at a time. So first we reduce to echelon form and find the rank. Reduce to echelon form. Reduce to echelon form and find the rank. So everybody knows how to find echelon form, right? Using R1. So first using first diagonal element, make below two elements 0. Using which operations? Row operations. So we have discussed very clearly in the previous lectures echelon form of a matrix. Now using R1, make the R2 element 0, R3 element 0. So R2 implies R2 minus 2R1. R2 means 2, R1 means 1. 2 into 1, 2, 2 minus 2, 0. R3 is 1. R3 minus R1. The pivoting row is R1. R1 is 1. Using R1, we are making below two elements 0. So the obtained matrix we call equivalent matrix. So A by B is equivalent to first row we are using. That's why first row there is no change. So 1, 1, 1, 4. Second row R2 minus R1. 2 minus 2, 0. R2 5 minus 2 into 1, 2. 5 minus 2, 3. Minus 2, minus 2, minus 4. R2 minus R1. 3 minus 8 minus 5. Okay, now 2 minus 2, 0. 5 minus 2, 3. Minus 2, minus 2, minus 4. 3 minus 8 minus 5. That is R2 minus 2R1. R3. So simple operation. R3 minus R1. First row, third row subtract. So 1 minus 1, 0. 7 minus 1, 6. Minus 7 minus 1, minus 8. 5 minus 4, 1. So is it in echelon form? We know very well what is the concept of echelon form. So number of zeros should increase. So using second row, make the below element 0. So 1 0, 2 zeros. Number of zeros should increase. Then only it is in echelon form. Right? Now using the R2, using 3, we have to make below element 0. That is R3 implies R3 minus 2R2. 2 3 is 6. 6 minus 6, 0. Then A by B is equivalent to first row. First row, no change. 1, 1, 1, 4. Since we are using second row, no change. 0, 3, minus 4, minus 5. Third row we are changing. R3 minus 2, R2. 0 minus 0, 0. 6 minus 2 into 3, 6. 6 minus 6, 0. Minus 8, minus of minus, plus 2 into 4, 8. 8 minus 8, 0. Fourth element, R3 minus 2, R2. 1 minus of minus, plus 5 into 2, 10. So 1 plus 10, 11. Now it is in echelon form. So because here 1 zeros, here 2 3 zeros. It is clearly it is in echelon form. So it is in echelon form. It is in echelon. The final one. This is in echelon form. So since it is in echelon form, we can decide the rank of the matrix A, rank of the matrix B. So what is the first of all rank of A? Rank of A means, so don't consider the last column. So till here it is A, till here it is B. Don't consider this last column. Then you will get the rank of A. How many non-zero rows? 2 non-zero rows. So last row is a 0 row. So only if you consider the A, the rank of the matrix is number of non-zero rows in the echelon form. So that is the rank of A is equal to 2. Suppose if you consider the whole matrix, that is the rank of A by B. Number of non-zero rows will give the rank. So how many? This is a non-zero row, this is a non-zero row, this is a non-zero row. 3 non-zero rows. Now clear the rank of A is not equal to rank of A by B. So as per the cases discussed here in the previous slide, here look at the previous slide. So rank of A is not equal to rank of A by B. That is the third case. Rank of A not equal to rank of A by B. The system has no solution. So since rank of A not equal to rank of A by B, we say system has no solution. System has no solution. System has no solution means, what do you call a given system? Consistent or inconsistent? We have discussed very clearly. No solution means system is said to be inconsistent. So what is given? Show that the system of equations is not consistent. Inconsistent in the sense that is not consistent. Anything you can call. Right? This is about one problem we have discussed on the non-homogeneous system of equations where the solution does not exist. See, every equation there is no rule. All the systems should exist some solution. Maybe the exist, may not exist. Exist means two options. One is unique solution, another one is infinite number of solutions. So in the next coming video lectures, we discuss about the system of equations. In this system here already we discussed the solution of system of equations, how that exists. Especially we have discussed about the non-homogeneous system, right? So in the coming video lecture, we discuss about the homogeneous system and the non-homogeneous system also, both. Some more problems where the system has infinite number of solutions. Okay, both will be discussed again. So thank you.